Hello, I'm Zhilan, and today I will introduce our work, Modeling and Leveraging Analytic Focus During Exploratory Visual Analysis. This is a joint work with Ximing Wang, Wang, and David Gotz at University of North Carolina at Chapel Hill. In many real-world problems, analysts deal with information found in large and heterogeneous data sources. For instance, in social science, these sources include structured census data, unstructured social media posts, and large-scale social networks. In the healthcare domain, relevant data sources include electronic health records, biomedical literature, and so on. Traditionally, structured data are often managed by relational databases and visual analytic tools, while unstructured tasks are managed by searching engines and natural language processing tools. This separation of tools of structured and unstructured data management presents a big challenge when a data analyst tries to explore and synthesize information across data sources. The disconnect between tools means that the analyst has to take note of her own focus in one data and transfer it to another data. In an exploratory task, the analyst will inevitably go back and forth between data sources many times. The manual transfer of the analytic focus can become a tedious burden and prone to errors. Our research goal in this region is to computationally model a user's ever-changing analytic focus during exploratory visual analysis. Inferred from user interactions, if an accurate model can be obtained, it can be used as inputs in other tools to get new information in real time. This requires a unified representation of the analytic focus. Our proposed approach has been prototyped within a pre-existing visualization system in the medical domain. The prototype implementation leverages this focus model capability to capture all user interactions and continuously search PubMed abstracts for documents relevant to the user's focus. These relevant abstracts are displayed to users to contextualize the current visualization and to suggest the new opportunities for future exploratory analysis. Our prototype implementation is based on Cadence, a pre-existing open-source visual analytics platform designed to allow users to discover patterns in structured time-sequenced event data, such as EHR. The Cadence platform includes a coordinated set of interactive visualizations. Here we introduce two components that worked closely with our prototype: the milestone-based timeline visualization in the middle that allow users to filter based on temporal constructs between events, and the coordinated scatter plus focus plot on the right that allows users to quickly identify new event types to incorporate into the timeline to help separate patients with different outcomes. Our focus model is essentially comprised of a list of concepts with corresponding importance scores. A concept here refers to a meaningful data attribute in the modern domain, like attributes of data records in a structured database schema, for example, a disease term. In the visual analytic process, each concept is usually associated with one or more user actions such as selection, filtering, or aggregation criteria. Here the plot shows how an action involving a concept will affect the importance score of the concept. At T1, the importance score rises to a value that is determined by the action time, and then it decays gradually until other action at T2 increases its importance score again. Finally, the focus model is comprised of a list of concepts with corresponding dynamic importance scores over time. We then leverage the focus model as a representation of the user's information need and use it to retrieve relevant documents from a full text index of PubMed abstracts. To evaluate the accuracy of the model and the user interest in our general approach, we conduct a user study using our prototype. The participants are assigned a task exploring medical conditions given certain outcomes. They are asked to describe their current analysis every 6 minutes, and we then show them our computed focus model and ask them to compare that model to their own descriptions. Overall, our focus model achieves high accuracy, and participants provide positive feedbacks on the helpfulness of the focus model and abstract previews. Here comes to the conclusion. So we present a formal model and algorithm to capture analytic focus in exploratory visual analysis. We do contextualizing visualized data patterns by surfacing articles relevant to current focus. Our prototype application in medical data analysis showed both the focus model and retrieved articles are helpful in an exploratory task. More details can be found in our paper. Thank you.